let's just start with a very interesting topic, which is nothing but called as the Euclid's division algorithm. But first of all, let's just discuss about what is the meaning of algorithm only. What is the meaning of algorithm? So algorithm is basically a series of the steps which we can follow in order to solve any particular question. So algorithm means a particular series of the steps, or it provides us a procedure to solve a particular question. So Euclid's division algorithm basically takes the help of Euclid's division lemma in order to find the HCF, that is the highest common factor of the two numbers. So this algorithm will be used in order to find the HCF of the two numbers using the concept of Euclid's division lemma. So let's just start with it. First of all, we will say it is used to find the HCF of the two positive integers, say a and b, in which a is always greater than b, and apply the Euclid's division lemma to a and b with a is greater than b and the condition that a is equal to bq plus of r, where the value of r is lying in between 0 and b. Now, as we know, the meaning of algorithm means a proper steps or a series of steps. So let us suppose we have two numbers a and b, and we have applied the Euclid's division lemma to a and b, and we are now writing those two particular numbers in the formation of a is equal to bq plus of r. So now the further step will be like, let us suppose remainder is either can be equal to 0 or either it cannot be equal to 0. So the next step would be like, after applying the Euclid's division lemma to the two numbers, we now have to talk about the remainder. So either the remainder can be equal to 0 or either the remainder cannot be equal to 0. So let us suppose we are talking about the two cases in which we are talking about either the remainder can be 0 or either the remainder cannot be 0. So let us suppose if the remainder is 0. So yes, if the remainder is 0, then the answer will be like B is the HCF of A and B. If the remainder of the two numbers will be like 0, then the B will be called as the HCF, that is the highest common factor of A and B. But let us suppose the remainder is not 0. Let us suppose if the remainder is not 0, the answer is no. No means the remainder is not is equal to 0. Then you have to repeat the step 1 again. Means go to the step 1. The step 1 is applying the Euclid's division lemma with a is equal to b. Now we will take the value of a as b and we will take b as r or r as b. So we have to repeat the whole step or whole procedure again till we get the remainder as equal to 0. So this is nothing but the Euclid's division algorithm, which involves a series of the steps which we have to follow in order to find the HCF of the two numbers a and b. So let's just apply the Euclid division algorithm to the questions. So let us suppose we are talking about some of the questions as the sums based on the Euclid division algorithm, in which we have to find the HCF of the two numbers. So let us suppose I'm talking about the very first part, which says that 135 and 225 are the two numbers, and you have to find out the Euclid division algorithm. Using the Euclid division algorithm, you have to find the HCF. The second is 196 and 38220. So let us suppose I'm solving the very first part over here first. So let if I am dividing both of these parts first, and now we will solve the particular first part. So let us suppose I'm writing the solution set of it, and we know that we have to apply the Euclid division lemma over here, and by using the Euclid division lemma, we know that if it is a, if it is b, so we know that a is always greater than b. So 225 is greater than 135. It means that we have to divide 225 with 135. So let's just divide in the corner area. So we have 135 and we have 225. We have 225. So let's just divide it, 135 to 25. So if we'll take 2, then it will be definitely more than 225. So 135 into 1 is 135. So the remainder will be like 0, and 12 and 3 is 9, and it is cancelled out. So it is nothing but 90. So it is nothing but 90. So this remainder over here is not is equal to 0. The step number 2 was like apply the Euclid division lemma, and whenever you are getting the remainder is non-zero, you have to repeat the whole steps again. So let us suppose I am writing it in the formation of Euclid's division lemma. So it can be written as dividend, that is 225, means A 225 can be written as BQ plus of R. So it is 135 into 1 plus of 90. The remainder is not is equal to 0. So let us suppose I am writing it as A is equal to BQ plus of R formation. Remainder over here is not is equal to 0. So we have to repeat the steps with the remainder and with the quotient, with the divisor, not the quotient, with the divisor, that is with 135 and with 90 we have to repeat the whole criteria again. So we have to take 135 and 90 again. So let's just start dividing these two numbers again. So as we know, we have this one, let us suppose we are considering as step number 1, and now we have two numbers as 135 and 90, and we do know that 135 is nothing but greater than 90. Now divide 135 and 90 again in the formation of A is equal to BQ plus R, and write it in the formation of A is equal to BQ plus R. So let us suppose I am dividing it over here. It is 90 and it is 135. So let's just divide it again. Let us suppose we are talking about 90, and 90 into 2 is obviously more than 135. So we are taking 90 into 1, 90 again. So it will be like 5, and it will be like 4. So it will be like 45. Again, the remainder is not is equal to 0. It means we have to further apply the Euclid's division lemma to the remainder and to the divisor. To the remainder and to the divisor. But let us suppose I am calling this equation as 1 and write it in the formation of the Euclid's division lemma again. So we can write it as 135 is equal to 90 into 1 plus of 45. Again, let us suppose I am calling it as equation number 2. So this is our step number 1. This is our step number 2. So let's just move on further. We have to take the number 90 and 45. So 90 and 45, in between both of these numbers, obviously 90 is greater than 45. Divide the two numbers. When we will divide the two numbers, 90 and 45, we do know that 90 and 45 into 2 is nothing but 90. So the remainder is now 0. The remainder is now 0. Now we are done with it. When the remainder is equal to 0, then the value of B is nothing but the HCF. So it can be written as, the third step can be written as 90 is equal to 45 into 2 plus of remainder, that is 0. So at the end, whenever the remainder is equal to 0, as per the Euclid division algorithm, whenever the remainder is 0, then the B value that we are getting in the Euclid's division lemma is nothing but called as the HCF. So here B value is nothing but 45. So at the end, the HCF of the two numbers, so we can write it in the formation like this. HCF of the two numbers are 135, 225. 135, 225 is nothing but 45. So this is nothing but my answer. So you can write it in this formation that the HCF of A, B or B, A, it is of the type 45. So the HCF of these two numbers are nothing but 45. So I hope the concept of applying the Euclid division algorithm is all clear to you, that you have to apply the Euclid division lemma till the remainder is nothing but is equal to 0. Now let's just move on to the solution set of the second part. The solution set of the second part would be like, as we know that the number 38220 is obviously greater than 196. So let's just divide these two numbers. So 196 will be the divisor. Again, the number 38220 will be the dividend, and let's just start dividing it. So 196, 196, the remainder will be like 6 and 8 and 1, and we can take 2 from above. Further again, 196 into 9, it will be like 4, 6, 7 and 1. So let's just subtract these two again. So we get the answer as 8, as 9, it will be 0, and furthermore we can take 0 from above. So 0, so it will be like into 5. 196 into 5 is nothing but 980. It is 980, so the remainder is nothing but 0. So here the remainder is 0. It means that the value of B is definitely the HCF. So this is nothing but the HCF. So let's just write it in the formation of the Euclid's division lemma. So we can write it as 38220 can be written as 196 into 195 plus remainder as nothing but 0. So this 196 is nothing but the HCF in between the two numbers. So the HCF in between the two numbers 38220 196 is nothing but 196 is nothing but 196 again. It is 196 again. So this is the highest common factor. This is nothing but the highest common factor of these two numbers. I hope the solution set of both these questions using the Euclid division algorithm is all clear to you. So this is all about finding out the HCF of the two numbers.